Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night, and I have Rex in the studio again.
Hello, Justin.
How you going?
Good, yes.
With some very exciting news and findings from a recent event, which we'll go into in a sec. But first of all, before I commence, we wish to acknowledge the Tasmanian Aboriginal people as the traditional owners of the land and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge and the culture and hopes of Aboriginal Tasmania. So, there you go. Now, exciting news, Rex.
Yes, because last week you asked me to do a talk and I had to say, well,
that was terrible.
Nothing's happened, but I'll tell you about what I know about nothing.
There you go.
And
it all changed.
All changed. And last week I showed this next slide, if we just go to it.
If we go to the next slide, there we go.
And you will see that it said that on the 24th, the KP index was sort of in the early morning, which is really the 25th for us, was going to get up to 5 and maybe 6. But because that's morning, I wasn't really convinced that that was going to be...
Something was going to happen?
Going to be that useful.
Okay.
What is interesting and just sort of look is we got an opening which was rather spectacular, which started at about 1200 on the 23rd, when the KP index is only 2.
Well, there you go.
Yeah. And continued up to, I think, about 0900, where the KP index was only 3. And...
I think this KP index is a furphy, but anyway.
And the reality is, after that, when the KP index was sort of suggesting it would be better, we got absolutely nothing.
Yeah, I think it's a furphy.
I actually no, I don't think it's a furphy.
Okay.
I actually think we wouldn't really have expected anything on the 24th because it was in the daytime.
Yep.
just for Lex's benefit, it's the problem with the daytime is that we're on the side of the sun, and the actual solar wind passes to the other side of the Earth and comes back in the magnetic field. So it's better at night. It's also better because you can see it if you want to see it. But for radio, you wouldn't necessarily mean it. But so this was the opposite of what I was expecting, and I was watching the Auroral oval data, which gives you a sort of 30-minute forecast.
Oh, okay. Okay.
And it was starting to look a bit interesting by about 0900, which I think is about 11 o'clock. No, about 8 o'clock.
8 o'clock. Yeah.
Our time.
Yep.
And no, it was probably a little bit later than that, and I'm thinking, should I ring up Brodie?
Should I get everyone excited?
Yeah, because it didn't look really very good, and Brodie, of course, has got a
he
9
looks
months,
after, correct,
9 months old
child.
baby, and so forth. But I plucked up courage and rang him. And he's very good, so.
And it paid off.
And I said, look, I think it might be worthwhile, and he started listening for me, but there was nothing there.
Okay.
And then about 12 o'clock at night, and a bit before 12, he rings me up. He says, I'm starting to decode you. We thought, well, this is pretty interesting.
There you go.
So, the reality is, on the 23rd, there was a spectacular aurora, and this next slide will show you.
Absolutely spectacular aurora.
I think you will have to look around. Oh, can you see it? Yeah. This is from Franklin down the Huon.
Lots of colour.
And I think someone, Gil Dayton or somebody...
Gil Dayton? Yeah.
Put this picture on the web. I'm not sure exactly what time, but it must have been some time in the evening on the 23rd. And so this sort of confirmed the results we were getting by radio. And even more interesting was the next slide, where there's the red aurora there in Florida, in the USA.
No, that's interesting. That's...
Well, I think it's a sort of a mountain, and I don't quite... Unless the
so
whole thing's...
higher up the mountain, you're getting the reds and then the greens down the bottom.
Well, I'm not really sure.
Okay.
It may be the photo's skewed or something.
Yeah.
But the reality is, here's someone in Florida receiving Aurora, which
now, Florida's pretty close to the equator, isn't it?
Well, it's actually not as close as you think. It varies from 25 to 29 degrees.
Oh, okay.
So
sorry.
Yeah, it's not much closer than sort of 35 degrees, like I've worked into Ballarat on Aurora in Australia. So, but there's a nice website called spaceweather.com, and
where they post all these wonderful shots.
They were a bit excited that it had got down to Florida and saying this is sort of a once in 20-year event and so forth. So
good stuff.
It was certainly interesting. Now, next slide. This is from Andrew Klekocuik, who's down in Kingston, just south of us here, and he's got an all-sky camera which he's able to extract a vertical cross-section looking directly south, and then he codes that up and produces a diagram like a strip chart in terms of time. Now, the interesting bit, if you look at the time at the bottom, is from about 11...
Oh, sorry.
From about 1200, which is when I started to see the Aurora, he started to see the Aurora
Right here.
right there, and his takeoff is not that good, so he loses about 5 degrees.
Seeing colour though.
Yes, but there was significant aurora going quite high up into the sky.
Correct. At 2 o'clock. At 1400, sorry. Yeah.
So, now, just for information, the earlier stuff is cloud with darkness, and then cloud,
So this is cloud with darkness in
and
here.
this is probably cloud at in
cloud.
daylight.
Yeah.
So
And then this one is going into the morning.
But still seeing some aurora just before it.
Oh no, well and truly.
Yes.
In fact, that event at the 1400, that's
Well,
pretty significant.
That's right. And if in fact the auroral oval had moved such that it was at an angle of maybe 10 or 15 degrees down at Kingston, then it must have moved very rapidly towards us. And if we go to the next slide...
I'll just point out before we go, that's the Milky Way.
Yes.
So that's clear sky with stars.
Yes.
And you can see the stars have sort of moved.
Yes.
But that line through here you can see is the density, the middle density of the Milky Way.
Yes. Now I'm not sure what angle the Milky Way would be.
Well, if that down the bottom south, oh no, that doesn't make sense. Because it's normally upwards.
It's upwards in degrees. So would the Milky Way be 25 degrees?
I don't know. We need our astronomer. Have we got an astronomer? Because we've got lots of people online right at the moment. And hi to Ron and Andy. If we've got an astronomer or maybe Andrew or somebody online who can let us know, that'd be fantastic. So, but
it means that the aurora was going quite high.
Well,
maybe 20 degrees up or something like that.
Now, do you want to talk about the Keogram?
Yes.
This is a fascinating way of representing it.
That's right. The Keogram, the word Keo is a contraction of a Inuit word for the Northern Lights, for the Eskimos, and an Australian who was working on Aurora from Adelaide, I presume Adelaide Uni at the Mawson Institute.
Yeah.
He invented these Keograms and named it.
Okay.
Which is a story that
Oh no, cool.
Andrew told me.
Yeah. Okay. Fantastic.
And a fella named Jacker. I know his son because he's
Martin Jacker.
No. Anyway,
but he was Mawson Institute.
He was at Mawson.
He was the mover and shaker of the Mawson Institute.
Yes.
Well and truly.
Yes, that's right. And he was an auroral person. So
Yes. Yeah. I met him once when I was an undergrad at Adelaide Uni.
Okay. Now, what I want you to sort of remember that squirt up there, where it went high, and then we'll look at the next slide.
So this one here at 1400.
Yes.
All right. Now, next slide.
Now, it doesn't show up very well, but there's a whole lot of red. I will show you on where it is.
Okay.
The red shot up here.
Here. Yeah. Okay.
And that sort of coincides
with the 1400. Yeah. Okay.
With the aurora that.
The visible aurora.
With the visible aurora.
Yeah. Okay.
Okay. Now.
So just to give us, so to scale across the bottom, we've got the 23rd of March, so this is the 24 hours of the 23rd of March.
Yes.
And then we're into the 24th of March.
Yes.
Yeah. Okay.
Now, the striking thing about this, which is different to all the previous ones I've looked at,
Yep.
is that the signal was there, then it disappeared completely for a couple of hours.
Yep.
And then it was there again.
Yep.
And then it came back. And when it came back,
Sorry.
it was of a different nature.
Correct.
It wasn't scattered as much.
It was quite coherent.
Now the red is the actual frequency of the signal, the audio frequency,
Okay.
which is a measure of the Doppler shift
Okay.
off the Aurora.
So you would say this was quite uniform in Doppler shift
compared to what
compared to over here, which is
Yeah.
all over the place.
Now, Andrew's view is that the actual speed of the solar wind was more consistent towards the end of the event, and that's why you don't get so much variability.
Okay. Now, you said solar wind.
Yes.
So this is not a CME event.
That's not quite right.
Okay. Tell me more.
The solar wind is involved in CME events.
Yes.
And this particular event, which we're going to go on to shortly.
Okay. Right.
But mostly, well, I think most CMEs, coronal mass injections, are a function of sunspots.
Yes.
But we'll see that this event really wasn't related to sunspots.
Okay.
So let's go on next.
Let's go to here and then
Now,
go on to
this is what the NOAA, National Oceanographic Administration, Oceanographic and Atmospheric Administration, model of the Aurora based on their data
the data. Okay. Yep.
was showing, and that it was up at least almost touching Tasmania.
Yeah. Well and truly.
And of course, I'm trying to work someone in Victoria, but they're only about, well, probably 700 kilometres further up.
Yep. Yeah.
And basically, you can see a radio aurora up to about 1,000 kilometres. So
There you go.
it would have been in range. It started a little bit before 12:33, but that was the first time I was smart enough to take
Okay.
a picture. So what we'll now do is we'll go to a spreadsheet.
Wow. Ooh.
I think.
Now he's really.
Now, this is the same diagram as we've been looking at.
Oh yes.
And we just scroll down, you can see all these decodes where CQ VK7MO is
in here.
And now I think there was a false decode in there. Did you see one?
Hang on. Let me go to.
Can you make it bigger? Yeah.
I can. Yes, I can actually. So that's the top of the list.
Yeah. Oh no, that's
No,
not,
I don't think there was, because see, this is VK3MOP.
Anyway, I did get about 3 false decodes in a total of over 1,200 decodes of this event,
That's not bad.
and all the rest were correct. Now, given that the Auroras, if you look at the frequency, which is G, the column G,
yeah,
you can see it's varying all over the place.
600, 400, 200. It's all over the place. Yeah.
So
900.
you're trying to decode a signal that's varying
1,000.
everywhere.
1,000.
And
900.
it's getting perfect decodes. Now,
that's amazing.
those of us who've listened to Aurora, we know how rough it is even on 6 metres, and it's 3 times as rough on 2 metres. And yet this program
is
decoding it almost 100%.
That's amazing. That is absolutely amazing. Up to 1200.
Yes.
So 1200 to 200 hertz. That's how much it varies.
It's not averaging, is it?
No.
That's just off the
These
chart.
are individual decodes of each time.
So that's that. We've just scrolled through the 1200 of them.
Yes.
So yeah, that is just amazing.
Yes.
Okay, back to our
We'll go back to the
presentation. Okay.
Now we'll go to the next slide. Now, this is the Australian KP index as it was measured after the event.
Okay.
And you can see where we got auroral signals, and there were the gaps that we saw in the previous diagram. And in loose terms, the signals occurred when
The KP was high.
when the KP was high.
Apart from that one at the beginning of the 24th of March.
Yes.
Do we know what that was about?
And the one before that, when it was 5 and we got nothing. So,
That's fascinating.
yes.
Okay.
So you got to give KP a little bit of latitude.
Correct. Yeah. I think. Yeah. Okay.
I mean, sure, if KP is forecast, it's worth trying.
Yeah.
But don't necessarily say it's going to happen.
Okay.
Okay, we'll move on now to what really happened. Now, previously I've been watching sunspots, and you can see that top
That's
picture.
the top. And in fact, we featured this particular sunspot here
Last week. And we were thinking, when that moved across, there's a chance that...
Yeah.
And I think that prediction that on the 24th, there in the morning, it might happen, was probably based on that.
We'll call that one Doug.
Yes. However, what was happening at the same time, if you look at the sun in UV rather than just visual light, there was a gigantic area which basically, where the magnetic field lines allowed the solar wind to escape.
So this picture, Rex, is that an actual picture of it? Like, that is the actual hole. There was a big dark area in UV, in the UV spectrum.
That's what they say. Yes, they might have.
Because that is enormous.
It's. I mean,
Like
the little spot up the top is probably the size of the Earth. So.
But that is just off the show.
Yes. Now.
And the interesting, I assume, the top image is the same view as the bottom image, but just in the different part of the spectrum.
Yes,
Is
that's right. At the same date.
So there's this enormous hole in a UV hole, whatever that means, that you can't see in the visible light spectrum.
Yes.
Okay.
Now they try and explain this.
Yeah. Exactly.
Where did you find that?
That's currently.
Oh, that's what it is currently.
Yeah.
But and it's
Very
actually,
good.
Just Lex, just give us that.
There's no hole.
But there's a huge big hole. This is the.
How did you find that so quick?
This is. There is a big hole.
Oh, there is a small hole. Well, relatively, yes.
Well, in compared to the Earth, that's a big hole.
Yes.
Like, that's multiple Earths across.
But last week it was, wasn't it?
Yeah.
Versus visible versus UV. This is
Now,
okay. Okay.
I don't know
Thank you, Lex.
how often these holes occur, but just relying on sunspots is not necessarily going to predict
Hey,
all the options
well and truly.
of getting auroral propagation.
Now, my question is, and this goes to your earlier observation around when I asked the thing about solar winds, is the amount, not the amount of energy, but the energy being pushed towards us? Because my understanding of a coronal mass ejection event is things get pushed out with great force.
At great speed, yes.
And in fact, you see those wonderful images of those flares coming out the side of the sun, for billions of kilometres or whatever it is. Whereas if you just open up a hole and the solar winds pour out of it, I assume.
I think they're still the same substance, like electrons and
so
protons.
lots of really ionised, lots of high intensity energy.
Particles at rapid speed, which will ionise the gases when they get to the Earth.
When it hits the Earth, yeah.
So I think that the process may be not that much different.
Okay.
But
maybe the amount of energy is, and it goes to that third image, where it is much more. It looks much more coherent from a Doppler shift point of view.
Yeah.
But anyway, sorry.
No, that's all right.
I find this fascinating.
So then the final slide is from the same site, where they basically admit the forecast did not call for this.
Oh, so they admit they didn't potentially get it right here.
But they talk about a crack had opened up in the Earth's magnetic field. And what I suspect actually happened is the sun was opened up and pouring all this stuff at us.
As well
as a crack opening up and letting it into the Earth. Maybe it didn't now matter whether it was day side
or the KP was 2 or 3, and it doesn't really matter. It's just
and the reason we got sort of 3 bursts of signal was the crack opened and closed a few times.
Okay.
Now, of course, in the past, hams have done CW on SSB and Auroral on SSB and CW, and they've got no systematic way of recording the Doppler shift and what's going on, whereas we can start to see some of these effects with a digital mode that measures the Doppler shifts. So,
well and truly.
Yeah.
And so, actually, we've got a few more people on. Lionel from New York State. Good morning, evening, Lionel. Andy, David Bannister. We've got Ron, Man, Dan, and Nick, VK3BA, as well. So yeah, we've got a few people on. Welcome. So yeah.
All right.
Well, that is fascinating, Rex. We've now got more factors to include, rather than probably explaining. Yeah, okay. And cracks in the magnetic field. I'm going to look that up now. That's just got me fascinated. Cracks in magnetic field. Yeah. I wonder how often that happens, and what other effects it causes.
And were we just dead lucky to get some cracks in the Earth's magnetic field when the sun's had opened up at the same time?
Well, hey.
And if these events don't happen very often, you'd never pick them just operating sideband. You'd say, oh, there's no Aurora now.
So broad.
Oh, no, well and truly. Did I mention this last time? I have heard Aurora on 6 metres. That's how I know it's that woodpecker type, that rapid, like machine gunning. That's how
I think it's broadband noise with a narrow it comes across
Yeah.
Yeah.
like that.
And it can be quite rapid. Those changes are quite rapid.
The audio voice quivers
Yeah.
Yeah.
rapidly. Yeah.
Because I remember switching on 6 meters and going, what the hell is that?
Yeah.
And it was somebody on 6 meters, obviously off of an Aurora, and I didn't take much notice of it. But then I think I might have come up here, and it might have been you actually, or somebody said, "Oh, did you hear the Aurora the other night? You know, see the Aurora and whatever else." I went, it was about the same time as I was hearing it. But anyway, I didn't try to transmit.
I mean, 6 meters is all these frequency variations are 1/3 as much on 6 meters,
Yep.
which makes it easier.
Yeah.
Now,
So what's next?
well, understanding things like why is it positive in the evening? Positive in the evening and then negative after midnight.
Yep. Okay.
In general, we need a lot more data to be sure and try and understand that.
Okay.
I have, when we first did this, which was actually, I think it was the 27th of December.
Yep.
I gave a little talk on this in January. Yes. And only today.
Only today this appeared in my my letterbox, and guess what? There are 2 articles by Mr. Moncur in here. The very first one is Q6515C, a digital mode for auroral scatter.
So hopefully we have sort of here in VK told the rest of the world how you can use digital modes on Aurora.
On Aurora. Well, and I hope, because some of the contributors to this magazine, regular contributors to this magazine, and especially the ones that seem to be the ones that are machining up SHF horns and all sorts of stuff, are up, that would well and truly be in the Aurora Borealis Arctic Circle sort of stuff. So, yeah.
Well, certainly things, places like Sweden, Norway are right up there. We have got a special advantage that the auroral oval is offset towards Australia. In the northern hemisphere, it's sort of more offset towards eastern Canada.
So North America.
Yes.
Yeah. Okay. We just had a comment. David Bannister, who is a new person on, I know, the Discord channel, cracks in the magnetic field is known as the Russell-McFerrin effect.
Yes. Well, and one of those was the guy at Adelaide University.
Oh, it was either Russell or McFerrin.
Yes.
Okay. And mostly when both day and night are equal in length,
At the equinox.
The equinox.
And in fact, if you go back a slide.
Oh, hang on. Ooh, here we go. This is tricky. This is very tricky. Oh. Push the right button, Justin. Go back a slide. Go. Yeah, we'll get there in a sec. Working on it. There we go.
They talked about this as being in solar wind will reach Earth then. Oh, it's actually fallen off the end to that, but
Oh, okay. Only on an equinox.
It talked about the vernal equinox.
Okay.
And I didn't know what that is.
What is it?
It actually means the equinox that happens in the spring, but
But reversed in the southern hemisphere.
yes.
Yeah. Okay. So it's us going into winter. Autumn. Sorry, us going into autumn.
So this was a vernal equinox, except that we didn't recognise it because.
Or if you're in North America, it's the fall.
Yes. So just terminology.
Okay. No, fantastic.
All right.
That is fantastic, Rex. And also, we're obviously we're not going to feature this tonight if we get some time, but we'll feature this in a couple of weeks' time, because next week is our presentation night. But this has some interesting articles, including the next of Rex's articles, which, if you came along to the Tassie Ham Radio Conference and Expo back in November, you would have heard the other article, which is results and analysis of attempts at extending the 10 gig terrestrial world record in the Hawaii-California path by Rex et al.
Yes.
So, yes. So that's one of the other articles, as well as there's a fascinating little simple 6 metre transceiver called the El Burrito.
6 centimetres.
Sorry, 6 centimetre. Oh. Yeah, sorry. Be a bit bigger than that, wouldn't it?
It's the
centimetre.
Wavelength,
Correct.
not the size of the printed circuit board.
Correct. Mind you, I actually like his, because he's made a whole lot of other pads on the printed circuit board to, I assume, move that connector around. Anyway, we'll feature that in a future
to us when it
future
goes in the
program.
box.
Very good. Yes. And this is by somebody who we're talking about, which is OE8FNK, who would probably be in a region that would be able to see the Aurora,
Yes.
Borealis.
Yeah.
So anyway, that's fantastic, Rex, and I look forward to the next event and the next analysis and building our knowledge. This sounds like the next conference. You're going to have some fantastic material. Just putting it out there.
Okay. All right. Thank you, Justin.
Thank you very much. Now, stick around, because the next thing I just wanted to cover was we had some articles about the 160 metre short vertical antenna, top-loaded. It's the VK3 XE design, so Drew Diamond's design, that I did a lot of playing with, putting together an article, and I got to the point where I wanted to answer the question of, for a 160 metre short vertical antenna, how many ground planes do you need as a minimum? Now, talk about going down a rabbit hole. There is a lot of material out there, and a lot of quite what I'd say is quite it's broadcast information. So a lot of the broadcast handbooks around broadcast antennas and all of this sort of stuff talk about ground planes and, you know, the minimum ground plane for a particular antenna and all sorts of things. So, and in fact, Kim 7KB, who may be out next door, put me onto some articles around ground planes. So, okay. So I wanted to answer the question, and I thought, well, we're at the Queen's Domain, which used to be a coast radio wireless station, and there was a very large, and I mean all of Hobart could see it, large biconical monopole that they had up. In fact, there's still the concrete blocks, and all the stays and everything is still out in the compound, as well as the very nice ground plane, 120 radial ground plane. So around the base of this monopole, they put in a copper pipe ring, and then put out 120 radials all the way out to the as far as they could go, and bonded this all to this wonderful. So I thought, well, if you want what's near perfect ground plane, we've probably got it. So that was great. So I thought, okay, we'll set up the vertical. We did try this where I was actually transmitting this end and we were receiving from, I was actually transmitting from somewhere else and receiving using a field strength meter, an absolute field strength meter, a Potomac field strength meter, broadcast field strength meter, which Kim very kindly lent me. And I got some really weird results. And I didn't believe the results, and I thought, initially I thought, okay, I ran a piece of coax from the base of the antenna quite a distance. It would have been probably at least 50 or 60 feet, 30 metres. And I thought, I wonder if that's actually creating a ground plane itself.
Yeah.
And I didn't believe the results that we got. So we revised the experiment. And what we designed was, I actually used it as a transmitting antenna. So I put the transmitter at the base of the antenna. So it was about, I don't know, 30 centimetres or so of coax from the transmitter to the antenna. Everything was sitting at the base of the antenna. I had a little keyer that was sitting there keying the transmitter. I was only putting 5 watts into it at 160 metres, 1.85. And we then used the antenna that comes with the field strength meter, which is a calibrated antenna, and calibrated it at the start and the end to make sure that nothing had changed and all of that sort of stuff. So I went through all of that process. And then Kim, and thank you to Kim who helped me out with this, we calibrated it here and took the reading, and then he took the field strength meter down to the barbecue area down the bottom of the hill and sat there in the barbecue area, and we went through no ground plane, the Queen's Domain ground plane, and then we went through, I had 4 wires which were 20 metres long, so 4 wires, and we did a measurement. Then I made it 8 wires, and I did he did a measurement, and then I made it 16 wires, and he did a measurement, and we got the results I was expecting, which was improving signal, absolute signal level,
With more wires.
with more wires.
Yep.
Well and truly, and I was able to make a bit of a judgment about the Queen's Domain ground plane. Because we've always had a bit of a concern about the ground plane, because it is damaged in a few places. And so what we were able to show, and I'll put this on the screen, I don't know how well this is going to show, but let's go to here and scroll out a little bit. So, okay, we'll go in the other direction, Justin. So, we did a calibration. The calibration was 8.2 volts per metre. So this is, or minus 1.8 dB on the scale, on the metre. So we did this at the beginning, and we then did this measurement at the end to make sure it was the same. So no equipment issues. Absolutely no ground plane, and no connection to a ground plane or anything, and we had absolutely nothing getting through. There was a little bit of audible noise. Now, no ground plane, but actually putting the antenna base, which is grounded, into the ground, because one of the problems we had last time was I had a huge difference between putting the antenna in the actual soil and out of the soil. And at the time that we did those measurements, it was quite wet up here. So there was actually really, I suspect was pretty good conductivity. So we just wanted to prove that we had dry soil, so we were able to do that because there was no difference, or very little difference. So then we isolated the ground and we connected it to the Queen's Domain ground plane. And wow, 1.6 volts per metre. So minus 16. We then went through and did the isolated from the ground, and the ground connected to 4 by 20 metre long ground planes. And Kim did progressive measurements as I was connecting up the ground plane wires. And it got progressively better until we got 1.46. So, not as good as the Queen's Domain ground plane, but not bad. 1.46 minus 16.8. Good copy. So we then went to 8 wires. We then went to 8 wires. So 8 wires, and you can see we got progressively better until we get to 1.65. Now, 8 wires is about the same as the Queen's Domain ground plane.
Interesting.
Now, so the Queen's Domain ground plane's either more damaged than I think it is, or I didn't have a good connection to it, and I think it might be the former, not the latter. I then connected up 16 20 metre ground planes, and I progressively, you can see here, Kim was progressively taking measurements, and we get to a point where I'm probably about halfway through, and it goes to 1.8 volts per metre and sits there for quite a while. And in fact, the difference between about the middle to the end is only about 0.02 of a volt. And so our theory there, this is the diminishing returns thing, where
It's half a dB.
on it's half dB, well and truly.
Yeah.
And so this, if we take this on measurement, this is 0.2 of a volt better than the Queen's Domain ground plane. So 16 is actually better than the ground plane that's in the ground, which supposedly is 120 radials. So I think we need to do some more tests with the Queen's Domain ground plane, but we can repeat this. We can certainly repeat this. We know where we took these measurements from. And then what I did was connect up both the Queen's Domain ground plane and the 16 20 metre long ground planes, and I actually got slightly worse.
It's only half.
Oh,
One of a dB difference. So.
And that could be error.
Yeah.
That could be error in measurement, because this is what we're talking about here is an analog meter. So you're reading off what an average is. So, but so that was the based on this. At a minimum, you put out 4 ground plane wires, and if you've got the luxury of putting out more, well, you put out more. And in fact, this is about what.
So what's the difference in dB between 4 and 16?
It's minus 16.8 versus minus 14.7. So it's 2
dB.
It's 2 dB.
Yeah, well, it's worth having.
So if you have got the luxury of having the wire and being able to lay it out, it's well and truly worth it. Now, this is going into an article about the 160 metre short vertical that Rogers asked me to write. So this will be in the actual article. But I just thought I'd relay. If you're into 160 metres, that's all the calibration point, and that's the measurement point and all of that sort of stuff. And it's all the measurement point is well and truly outside the near field and all of that sort of stuff. So it's far field measurements, and we made sure it was all out there and all of that sort of stuff. So anyway. There you go.
Is there any way of checking, with a sort of a metal detector, whether the ground plane actually is continuous?
We can certainly do that, and in fact, we've got a pipe detector that we can probably employ to use that. Inject the signal at the centre and then follow it out and see how far out.
Do they have to be ferrous metal?
No. Well, no, I don't think they need to be ferrous. I think it needs to. There's a conductive mode with them, and there is an injection mode with them.
Okay.
So you can actually physically connect to whatever you're trying to measure, as well as inducing a signal or a
Presumably
current.
these 120 ground planes were put down before the building was built, and they go
Well-
underneath the building.
Well, they certainly go around this building, because if you go around the outside, there's a big loop, and in fact there's some manholes around in the footpaths, and if you pull those manholes up, there's lots of bits of copper that all come to, and are sweated together and all of this sort of stuff. And in fact, if you look around, just behind Rex, there's a very large piece of copper. Rex and Lex. There's a very large piece of copper that sticks out of the skirting board there, which sticks out all over the place. So they could bond things to the ground plane. So the ground plane's pretty impressive.
When do you think the ground plane was put in?
Well, I think it may have been renewed before they put that biconical monopole in. And the only reason I say that is the concrete slab that's out there was put in for the biconical monopole, and the ground plane is around the outside of that concrete slab. So when they put that slab in, they then put the ground plane in. So I think they put it in when they put that antenna.
They probably couldn't put it under the building then.
Oh no. But and Ron, talk to me about finding the Queen's Domain ground plane. Okay, I will certainly do that. Thank you. So good stuff. And the Rex and Justin comedy show. Yes, Nick. We're here to please. We're here all week. So that's now. I just thought I'd finish off. During the week, parcel arrived. Many parcels arrived for me, which may or may not endear me to the Minister for Home Affairs. But anyway, this arrived in the box. Now, what is this? It is a 18650. So this is a lithium-ion or lithium polymer battery, one or the other. Lithium-ion battery tester. So this, and given all the symbols on it, I think we know where it comes from. But what it does is it enables you to, this is the device under test, and this is they actually put another one on here. You can put either USB-C in here and charge this one, but this one runs the device, and you can set it up to cycle the battery. It does a charge-discharge cycle, and you set up where you want it to actually stop and how many times you want it to go through, and it tests this battery here, and that's why there's some big resistors here that do get hot. So I think I might be putting a fan on this, but it enables you to test the 18650 batteries. I grab the lithium-ion battery packs out of old laptops, because what usually happens is one of them fails and the others are perfectly alright. And so, but the problem is, you may or may not be able to tell which one has actually failed because it looks exactly like the others. And so this enables you to then test them and actually then put them into another battery pack, which I've done an article on that earlier. So you can buy all of the hardware that you need to put together battery packs, lithium-ion battery packs. So this just enables me to more positively test batteries and not have to take battery packs apart afterwards, because you put, of course, Murphy's Law says that you put the bad one right in the centre of all the others and then have to work out how to get it out. So anyway, this is a wonderful little device. I think it cost me about $30. Landed here. It didn't take very long to get here actually, but enables you to check 18650 batteries. So yeah, that's just a thought for those people who are creating battery packs or wanting to test their lithium-ion batteries to make sure that they are actually working and they're up to capacity. So yeah, Little board, works really well. So yeah. Now, just a reminder, finish off with some reminders. Next week is our presentation night, the Reast presentation night. And what we will be having is talk on myth-busting magnetic loops by yours truly. Those who haven't been following the DATV nights, I've been banging on about magnetic loops for probably the last 6 months. And so what I put together is an article about all about magnetic loop antennas, the do's, the don'ts, the myths. I am actually demonstrating a magnetic loop antenna. So it will be the things I'm talking about. I will actually demonstrate with a transceiver, with a few other devices.
Is that next week?
That's next week.
Next week.
That is next week. It is the end of March. I don't know where that's gone, but hey, it's the end of March in a couple of days' time. So that's we will be streaming it. We will be going out on RF with that particular article. Now, for our May presentation, we've got FIO Marine coming in with their acoustically activated buoys. So that should be an interesting article. Then we're into June. Now, June is our centenary. Is our VK7 centenary of organised amateur radio in Tasmania. Then July is satellite weather imagery. So with Tony VK7 XTC and also Mike VK7 DMH. So there you go. So hello to Andrew, late to the party. We'll go back and watch later. Okay.
Which Andrew?
Andrew Elwell. And Andy Cowley and also Sean. Sean must be back home. So in the Valley of Leuve. So yeah, there you go. Now, it was very remiss of me not to say something about the fact that our repeater, which used to be just here, next to us, is now up on the mountain. So, and can I just say, is back on the mountain with its original call sign, VK7RHT, which is why we changed it. So we went back to the original call sign. The transmitter and a receiver is up there. There is a voting simulcast arrangement with the receivers. So there's a receiver here at the domain. There's a receiver up there, and there will also be a receiver at Grey Mountain. And they're all transceivers, all on the same frequency, all at once. How do we do that? Well, I'm glad you asked. That's probably a presentation a bit later. Anyway, we'll get Hayden in and he'll give us a talk on how it all works. But anyway, it's up on the mountain and it's back to its old call sign. So great work from the repeater group. So yeah. Anyway, that's it. Have a fantastic rest of the week. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And good night from me.
Good night. From Rex.
And good night from
Lex.
73.